When we look at a data set, we might ask the question, which value in this data set seems to be cited or located far away from many other values? Take for instance, if I have 1, 2, 5, 7, and 100. One value, 100, seems to be cited far away from the rest of the data values. The question is it truly far away enough to be considered an extreme value in this data set? Is it an outlier? That is another way to put that question. So that brings us to how to find outliers by hand. And to do that, the measures of position, namely the interquartile range, which is based on the third quartile and the first quartile, can be very useful in determining if a number is an extreme value or an outlier. Let's consider an intuitive example. Suppose that in a small town of 50 people, one person earns $5 million per year, and the other 49 people earn $30,000 per year. Do you think there is a potential outlier in this data set? I would argue that first, yes, there appears to be one, and that is because $5 million appears to be much, much higher than the income of $30,000 earned by other persons in the small town. Then we proceed to the next example. For the same context, that is, suppose that in a small town of 50 people, one person earned $5 million per year and the other earned $30,000 per year. We would like to determine both the mean and the median. Which do you think is a better typical value or measure of center of income in that town, and why? Let us get the computation underway. For the mean, I am going to have $5 million for the one person plus $30,000 multiplied by 49 other persons divided by how many values were added together? 50. This will be equal to 6,470,000 divided by 50, which gives a final answer of $129,400. Then, for the median, first we will need to order 49 30,000. So you have 30,000, 30,000. I will have to write 49 of those. So this will be 49 times. And then the last value will be the $5 million earned by the great earner. And then the median will be the middle value. So definitely the median is going to be 30,000 in this case. So the big question is, which is the better measure of center, or in English, which is the better typical amount earned by a person in this town? I would argue that the median of 30,000 reflects what the popular income is, or the more typical value, not 129,400. Imagine telling someone who makes $30,000 that they earn typically $129,400. Imagine the reaction that would generate. This is one of those instances where we have to be careful not to report the mean. The influence of the outlier, which is 5 million, has definitely skyrocketed or been a major impact on the mean and makes it not a true reflective value. So when you see a value that appears to be an extreme value, you might not want to report the mean. Rather, again, you want to report the median because the median is a resistant statistic. We now proceed to the next example where we would like to actually compute a measure that tells us when a value is actually an outlier or an extreme value. In this example, we are told that for the following 13 real estate prices, we would like to compute the IQR and determine if any prices are potential outliers. The prices are in dollars. So if you look at this data set, Do you think there are any outliers? That would be our first question. Let's do a hand-waving examination of the data set. I would argue that the number 5.5 million, in fact, 1,095,000, this is subjectively speaking, would be potential outliers. Based on my observation, the data points 1,095,000 and 5.5 million are potential outliers in my opinion. Well, the major thing that propels us to do extra work is that this is just an opinion. Is there an objective, formal way to check if these numbers truly are outliers? The answer is yes. How do we do it? We compute two things called the lower fence and the upper fence. We're going to get the values of these two quantities and they will mark off the inliers away from the outliers. In other words, the lower fence, I'm going to call it LF, and the upper fence, I'm going to call it UF. These two numbers would mark off the beginning and the end of numbers that are not outliers for this data set, and any number outside or above the upper fence or below the lower fence will be considered outliers. So, how do we compute the lower fence? This is given by the first quartile minus 1.5 times the interquartile range, whereas the upper fence is given as the third quartile plus 1.5 times the interquartile range. So it appears, or it stands to reason, that I'm going to need the first quartile, the third quartile, and the interquartile range. So I'm going to set about finding that first. Right here on the screen, I have all the prices already. So I'm going to go to statistics, summary statistics for a column, and I'm going to choose real estate prices. I can see that by default, many of the stats have already been chosen. I'm just going to go ahead and compute. And I just need Q1 and Q3 from here. So let me take that back to my working space. So here on my screen, I have the first quartile of 387,000, the third quartile 639,000, and the interquartile range is a derivative of both, which is Q3 minus Q1, and that gives 252,000. Now that I have all the three quantities I need, namely the first quartile, the third quartile, and the interquartile range, I am ready to compute the lower fence. So my lower fence, to begin with, will be equal to Q1, which is 387,000, minus 1.5 times 252,000, and that gives 9,000. Whereas the upper fence will be Q3, which is 639,000 plus 1.5 times 252,000. And that will be equal to 1,017,000. So, as it stands on the number line, my lower fence of 9,000 and my upper fence of 1,017,000. These are the two markers for the inliers. So I'll call them the inline data set, inliers, and every value greater than or lesser than the lower fence, greater than the upper fence or lesser than the lower fence will be considered outliers. So the question I need to ask myself is, the numbers 1,000,000 and 95,000, this is definitely a number greater than 1,017,000. So this is an outlier, as I suspected earlier, and 5.5 million is also greater than the upper fence. So it is also an outlier. So these two numbers, objectively speaking, and based on the formal test, the results of the formal test are outliers. With that concluded, we proceed to five-number summary, another concept called the five-number summary and box plots. This is just a collection of numbers that summarize a data set or a collection of data values. And here they are. You have the minimum value, the first quartile, the median, the third quartile, and the maximum. These are the five-number summaries. They can also be used to generate an informative graph known as the box plots. Box plots can give a good graphical image of where majority of the data values are concentrated. They are also very useful in showing the presence of extreme values or outliers. So, for example, we're going to look at this data set and we would like to make a box plot of the following data set. In order to do that, we note that the data set has already been ordered from the smallest, the minimum, to the largest, which is the maximum. So I am going to find the median. I have done that earlier. The median is 7. The first quartile is 2. And the third quartile is about 9. So now that we have the median, the first quartile, and the third quartile, and the minimum and the maximum, we are ready to draw the box plot. All I need to do is locate where 1 is, so I can see 1 right here. So let's zoom in here. I can see where 1 is here. I'm going to put a mark there. And then when you have 11.5, that will be halfway between these two, between 11 and 12. And then I would like to locate my Q1, Q2, and Q3. So that will be 2. I'm going to draw a larger line here for 2. And then next for 7, I'm going to draw a larger line there too. And then for 9, I have this larger line too. So I'm going to connect these points. And I'm also going to draw this. These extensions are called the whiskers of the box plot. And so this picture represents a box plot. Take note that we were able to use the minimum and the maximum because both of them are not outliers. It is also important to start a box plot with a scaled number line if you're drawing it by sketch, otherwise the box plot may not be useful. In today's world, we deploy modern technology in drawing box plots, and we shall see examples of that. On the next page, we are told that we have an example where a bakery tracks sales of its different bread products on a daily basis. The data for 22 consecutive days at one of its retail outlets are provided in the accompanying table. We'll see that in the table. We have to calculate the mean, mode, and median for each of the bread categories and write a short report that describes this data. We would like to use any graphs or charts that may be useful or helpful in describing the data. Include a box and whisker plot comparing all categories of data. And of course, we have the location of the data set in our files. So this is a template for that report. For white bread, for multi-grain bread, and for black bread. So let's see the data itself. Here on your screen is the data for white, multi-grain, and the black. Remember, these are the 3 types of bread sold by the bakery. So what we would like would be to get the mean, the mode, and the median for each of the 3 types of breads. In order to do that, let's go back to StatCrunch. I already have the data set in, so I can go to Stats, Summary Stats for columns, and I'm going to click on white, hold down the Control button to grab multiple. So white, multi-grain, and black. And I already have by default all of the descriptive statistics selected for me by default. So I'm just going to go ahead and click compute. I need for white, I have, I want the median, I want the mean. I can get these values from here. Well, I also need the mode. That appears not to be here. So if I want to do that, I can go to options, edit, and I would like to include the mode. So this is another thing I can do. So I can compute the mode if I want. This has multiple modes, and Black2 has multiple modes too. In any event, when your result shows multiple modes, if you would like to actually see for white and black, which shows that there are modes, but there are just more than one, you can go back to stats, go to summary stats, go to columns, and then I'm going to choose just white and black. For multi-grain, I already know there are no modes, so I'm not going to bother about that. So you have, I'm going to choose white and black. Okay, let me hold down that. Good. And in this case, I like to choose to find the summary stats. Well, if I use this, I will only get what I got earlier. So what I'm going to do is I'm going to X out of this and I'm going to go back to stats. I'll like tables this time and frequency tables for white and for black. So grab white, press down Control button to choose black, and then I want a frequency, just a frequency distribution, and to count. Okay, so it shows that, that's okay. I will be able to see, oh, it binned them. I do not want that. So I'm going to do that one more time. Sorry about that. Go to frequency, go to, I just want that of white and black. And I just want the frequency, and I like to compute. Want to do this? No, I do not want to turn it to a binning procedure. I would like to see the raw counts. So I can see that the number 508 occurs twice, and 820 also occurs twice. So for white, there are two modes, and that is 508 and 820. And for the frequency for black, it has 254 and 310 and 341. This is a multimodal distribution. So let me record that down. All of the statistics we got for each of the different breads have been recorded here. And from there, we would like to create a box and whisker plot comparing the quantity of the different types of bread sold. In order to do that, here I am in StatCrunch. I'll go to Graph, and I want box plot. Click on box plot. I'll grab white, multigrain, and black. I want all the three columns. And I'd like you to draw the boxes horizontally. This is usually a very good visual that helps us to observe the box plot from left to right. And so, click on compute, and I have the box plots. So immediately, I can immediately see that for white, I can see more sales going on. And for multi-grain, you have that one next in rank, and then for black. So I can go back to creating a report, a short report that compares the quantity of the different breads sold based on the summary statistics and the box plot we have just drawn. So let me minimize this again and let me write my short report here. So the order of the bread sold from least to greatest is black bread, black bread. So based on our observations, the order of the bread sold from least to greatest is black bread, multigrain bread, and white bread. The distribution of black bread is approximately symmetric. How do I know this? Going back, I can see that for black bread, the gap, the distances between the median and the whiskers, and here is about the same. For multi-grain, however, I can see that the box to the right is really big. This space is way bigger than this. So this is definitely considerably right-skewed. Well, I don't see much of a difference between this and this that much. So this, I'm going to call it as approximately symmetric. So with that said, that fuels the statement here that the distribution of white bread sold is approximately symmetric, while the distribution of multi-grain bread sold is considerably right-skewed. With that question completed, we proceed to the last question there on that topic or concept. And here we're told that the manager for Jiffy Lube Auto Service Center has collected data on the number of customers who agreed to purchase an air filter when they were also having their oil changed. The sample data are shown as follows. So we have to compute the mean, the median, the mode for this data. Let's do that. Here on your screen, I have the data set. I'm going to go to stats, summary stats for columns, and I would like just the mean, the median, and the mode. So let me choose median. Okay, I need to choose this too, and then let's go to the mode. All right, and I'd like to compute that. Oh, I did not select the column, so I get Jiffy Lube customers and compute. And I have the mean, the median, and the mode. You observe that all three are equal. So I have 19, 19, 19. This immediately tells me I'm dealing with a symmetric distribution. And on the second question, we have to indicate whether the data are skewed or symmetric. Definitely symmetric. And why is that? The mean is equal to the median. This is a behavior of the symmetric distribution. We would like to construct a box and whisker plot for this data. Okay, so let's see if we compute a box and whisker plot. So I'm going to close this and go to graph, box plots, and box plot of Jiffy Lube customers, and would like to compute that. Well, I can see this from top to bottom, not my preferred, so I'm going to go back, do box plot, this time still of Jiffy Lube, but I'd like to see it from left to right. That is, the boxes are drawn horizontally. So I'm going to check this box and compute. So I can see that there are some outliers, this dot and this dot. And this represents, if I move the cursor or the mouse over the data points, it tells me what values are considered outliers here. So this is in row 8, and the number there is 12. And I can see that the distance from here to here is about the same distance as from here to here. It's not significantly large enough. So this is definitely in support of a symmetric distribution. So, referring to your answer in part B, does the box plot support your conclusion about skewness or symmetry? Yes, it does. The distance between the lower quartile and the median and the upper quartile are about the same. So there is a clear justification here that the distribution is indeed symmetric. Based on the realization that the distribution of the data is symmetric, we can report that the typical or average number of customers who agreed to purchase an air filter when changing oils is the mean of 19 customers.